So this section's 10.3. Let me look at the problems. Describe the motion of the particle with position xy. I said t varies in the given intervals. All right, so let's take a look at this problem first. Okay. This is a problem number 19 in section 10.1. Okay, you are given x equals 5 plus 2 cosine pi t, y equals 3 plus 2 sine pi t. T is between 1 and 2. Okay. See, when you see this expression, right? You look at, okay, where's the x here? Okay, cosine, here's the sine. We know cosine square plus sine square equals 1, right? So you solve for cosine pi over t from the first equation, right? That's x minus 5 divided by 2, right? And the sine pi over t equals y minus 3 over 2. So therefore, right? So this is going to be square. Okay. Yes. They equal to 1. Okay. So then you have x minus 5 over 2 square plus y minus 3 over 2 square. Okay. So you can rewrite that equation. So this is a circle, part of the circle, at least, right? Part of the circle was coordinates 5 and 3, and was a radius 2. So this is circle. Okay. The question is where's the starting point? Whether I think it's only part of circle, because when t is between 1 and 2, pi over t is between pi and 2 pi, right? So I think it clearly between pi and 2 pi is this part. Okay. So here when t equals 1, here when t equals 2. Okay. And you can double check that, when t equals 1, right? Cosine, no, sorry, x is going to be, right? X is 5 plus 2 cosine, 5 plus 2 cosine pi. Cosine pi is negative, so it's going to be 3. Wait a minute. Okay, so, well, maybe not, right? So double, that's a cosine, yeah. So cosine pi is negative, right? And the y equals 3 plus 2 sine pi, which is just equal to 3. So that's equal to 3 and 3. Okay. Yeah, starting point, right? So the end point is that, when t equals 2, x equals 5 plus 2 cosine 2 pi. Cosine 2 pi is 1, so it's 7. And the y equals 3 plus 2 sine 2 pi. Sine 2 pi is 0, so it's still 0. So this is a point 7 and 3. Okay. I think that's all you needed to give. Okay. Yeah. Okay. That's all about this problem. All right. Now, to parameterize the curve in this space. sometimes we use an angle. Okay, so the typical example is a circle, right? How to describe circle, right? So this is a point, right? Right? We you know when you're given x squared plus y squared is r squared, right? The standard method is take arbitrary point x and y, then draw the line, right? Then you have the angle here, theta. So x is going to be r cosine theta, y equals r sine theta. This is a typical parametric equation for the circle. When theta increases, and you get the whole circle, right, from starting point. When theta equals 2 pi, and you get, you come back to the point. Okay. Right, so using this idea, I'm going to introduce so-called polar coordinates. So we can describe the point, forget the circle, just, yeah, this is a polar coordinate. Right. So in the space, you already choose the XY coordinate system, and then take an arbitrary point, right? So you can describe that point using Cartesian coordinates, X and Y. But you can also describe this point using two numbers. When you draw the line, you measure the length. The length is R, okay? Then you measure the angle. You rotate the x-axis counterclockwise, and you get theta. So we can use r and theta to describe the position of the point P. Okay, right? So this is called r and theta are called the polar coordinates of P. Okay, polar coordinates of P. Okay, they are so r and theta called polar coordinates of the point P. Okay. And the relationship is clear. So the relationship is x is r cosine theta, y equals r sine theta. Okay. And just because that, so you can also get the equation x squared plus y squared equals r squared. That's how do you determine r. You can determine each other almost. Okay. So given x, given r and theta, okay, you can get x, y, okay? So given r and theta, and then given x and y, you can get r theta. How do you do that, right? So you can try this. R is going to be r squared is going to be x squared plus y squared, okay? Then theta can be determined by two equations, either of them. Cosine theta is going to be x over square x squared plus y squared. And sine theta, yeah, I think I should use radical, yeah. Okay, so here we assume r is positive. Later on, maybe we can also allow r as negative, okay? So sine theta is y equals x squared plus y. Okay. This is how do we determine each other, you know. Given x and y, you can get r theta. Given r and theta, you can get x and y. However, I have to say that theta is not unique for the same point. Okay, so r theta that's not unique for the same point. Right? And x and y are unique. Given point, you get uniquely x and y. Okay, x and y, the unique for the point P. Okay, because you just draw a vertical line, draw a horizontal line, you get two x-intercepts. Okay, why R theta is not unique? Yeah, this is 2 points I want to make. Okay, given point, right? Point P, and draw the vertical line, right? You get the x. Draw horizontal line, you get the y. So that's why you get x and y, unique, right? However, for the same point P, here's R, right? Theta is not unique. The reason it's not unique is because I can rotate this coming back, right? So this angle will be theta plus 2 pi. So R and theta represent R and theta, R plus theta plus 2 pi represent the same point. Okay, and even you can also get a negative, so get a theta. Okay, so let's see. So this is the angle, right? I can rotate this clockwise, and this angle would be negative. Okay, so this angle is going to be called beta. Okay, so beta is actually it's beta is actually here. If that is a theta, okay, the relationship between is going to be negative 2 pi minus theta. Okay, why? Think about this is negative, first it must be negative, but the size of this angle is 2 pi minus the theta, right? So, but they have to put a negative sign there. Okay, so R and negative 2 pi minus theta is also represents the same point. Okay, but that way is actually is going to be R equals theta minus 2 pi, basically the same, just plus. So more general, R theta plus 2k pi. K can be 0, plus minus 1, plus minus 2. They all represent the same point. Okay? And then later on, we can even allow R to be negative. Okay, I is positive right now. I represents the length. Okay, I is going to be the length. Yeah, the length of this thing, so it's positive. But we can also, yeah, we'll talk about why we can allow R negative later on. Okay, so here's the example. Okay, let P to be square 3 over 2, and this is 1/2. Okay, so this is in Cartesian coordinates. Okay, so we try to find out. Okay, so this is x and y, right? Okay. Find I and theta, okay, for the same point P. Okay, the polar coordinates for the point P. Okay, so how can I do that? Well, we use a formula, right? So I is going to be square of x squared plus y squared, and the cosine theta equals x over r, right? And the sine theta equals y over r, right? So write down those formulas we need. So x squared I equals square root of 3 over 2 squared plus 1/2 whole square. So that's going to be 3 over 4 plus 1 over 4, which is just 1. Okay. So now all you have to do is just determine the angle, right? Some of you already know that. Oh, that's easy. That's fine. So I just do, follow step by step. Okay. cosine theta equals square root of 2. Sin theta equals 1/2. So that tells me this angle must be in the first quadrant, and we know theta, this theta must be power 6, okay? Because cosine power, sine power 6 is 1/2. Okay? So 1 and the power 6 is, this is the polar coordinate, okay, for the same point, P. Polar coordinate for the point P. Okay. But this is not unique. I just said that this angle pi over 6, right? I can rotate this coming back. So pi over 6 plus 2 pi is still. Then I can also look at pi over 6 minus 2 pi, okay? Which is going to be 1 negative 11 pi over 6. Now, to describe this, negative 11 pi over 6, actually from here all the way to here. So the size of the angle is 11 pi over 6. Put is 2 pi minus, right? This is pi over 6. But you have to put a negative sign there. Okay. So negative 11 pi over 6. Okay. So that describes the same line, same point on this line. All right. So let's rewrite again. So my x is going to be 1 times cosine pi over 6. Y equals 1 times sine pi over 6, right? Okay, so I'm going to change the expression a little bit. I tried to find the angle here, put a negative 1, cosine, negative 1, sine, okay? So what is that angle? That angle actually is going to be 7 pi over 6. 7 pi over 6. You can check that. Okay. 7 pi over 6. Okay. So what? Okay. Okay. So this time is I is negative. Okay. So 7 pi over 6. This is the angle. Here's pi over 6, right? 7 pi over 6 is just this line. You add, this is a pi, add pi to pi over 6. So from here to here, you see 7 pi over 6. So 7 pi over 6 is this line, okay? Any point on this line has the angle 7 pi over 6. But since I is negative, okay? So I is negative here, so how do you describe the point? If I is negative, so you have to flip over, okay? You have to, go to the other side. Negative means, okay? So you actually describe the same point. So this same point, I have another way to describe it, okay? Allows R to be negative. If I is negative, it's you have to go to the other side, okay? So this point here, this is if you use a polar coordinate, this point is 1, 7 pi over 6. So the other side, this point will be negative 1, 7 pi over x. So first of all, you use the angle determines the line. Then you choose a point, assuming I is positive. Then if I is negative, then go to the other side, so you're back to that point. So we can also say that negative 1, 7 pi over 6 are the polar coordinate. So we align the R to be negative, even, okay, for the point P, the same point P, okay, which is square root of 2 and 1/2. So same point P, you can use So here's the point. Here's the definition. Okay. As long as this is correct, regardless of negative, positive, R can be positive or negative. Okay. And the theta is not necessarily, theta can be positive, negative, doesn't matter. Then R theta called the polar, polar coordinate. Okay. Of the point P. Okay. What's the coordinates X and Y? Okay. So that's a definition. So R could be negative, but how do you describe the point if R is negative? And I just showed to you, right? So let's take a look at the if I and theta equals -2, right? -2 and 5 pi over 4, okay? Right. Plot plot the point in the XY plane. In the XY plane, okay? In the Cartesian coordinate system. So the couple ways to do. One is you simplify it. X equals R cosine theta, so it's -2 cosine 5 pi over 4. And the Y equals -2 sine 5 pi over 4. But you can compute it, right? -2 cosine actually you can you can compute it. This is cosine pi over 4. It's bigger than pi. Actually, this is negative square root 2 over 2. Okay. And this is -2. This is also negative square root 2 over 2. Okay. So the answer here is going to be square root 2 and the square root 2. Okay. Then you can also write this 2 times square root 2 over 2, 2 times square root 2 over 2. So you can even write as cosine pi over 4 and 2 sine pi over 4. You see? So clearly from this picture, you can also see that R2 and the pi over 4 is also coordinates for the same point. So R theta equals 2 pi over square 4 as a coordinate, as a polar coordinate for the same point, for P, right? For the same point. Okay, so it's easy to draw it. Okay, and this is a pi over 4. And the length is going to 2. Okay. Now, how can I, without doing this, how can I draw the picture directly? So here's this is a theta, 5 pi over 4, okay, right? And the 2, the length 2 is here. This is a 2, right? -2, you have to go the other direction. So this will be -2, okay? So because I is -2, you cannot choose that point. You have to choose a point opposite to that, okay? So that is a point I equals -2, okay? And the theta, okay? So this point I can describe in -2 and 5 pi over 4. And this point I describe as 2, 5 pi over 4, okay? So we are looking for, so you get the same point, but just describe it in a different way. All right, let's do the next problem. find polar coordinates and theta of the point square 3 negative 1, where r should be negative, theta is between 0 and 2 pi. Right, so there's a restriction here. R is negative. What we're trying to find out is x equals r cosine theta, y equals r sine theta. Okay, and here r is negative, theta is between 0 and 2 pi. Okay, yeah, theta cannot be 0, so just between 0 and pi. So we're trying to express, yeah. So in other words, x should be square 3, and y is going to be negative 1. Okay, how can I do that? Well, from here, I know x squared is going to be x squared plus y squared. This is always true regardless of negative positive, right? So that is going to be square 3 squared plus negative 1 squared, which is 4. So since I is negative, so I is negative 2, right? Yeah, right? All right, so now from the above formula, cosine theta is going to be square 3 divided by negative 2, right? So negative square 3 over 2. Sine theta is going to be negative 1 divided by negative 2, so it's 1/2. So where is the angle? I think the angle is in second quadrant. It's clear. Okay, the angle is in second quadrant, this angle. Because cosine is negative, sine is positive. So without too much trouble, one can get the angle. So this size will be 6 pi over 6. So theta, that is a reference angle, actually. Reference angle, it's easy to find out, it's pi over 6. So theta should be equal to pi minus pi over 6, 5 pi over 6. Okay, that is the angle. All right. So you find in the expression x equals negative 2 cosine 5 pi over 6, y equals negative 2 sine 5 pi over 6. How can I describe this point based on this information? Well, step 1, you determine the angle. Since I is negative, so you have to go the opposite direction. And you put the point here. So this is the point we're talking about, okay? So r theta equals negative 2, 5 pi over 6. But this matches with my picture. This is indeed x and y is going to be square 3 negative 1. So yes, you know, if a x, y coordinate square 3 and negative 1, then point must be in the fourth quadrant. So that matches what we discussed. Okay. Right, so that's good. Anyway, there are multiple expressions, okay? Multiple expressions for the polar coordinates for the same point. Just because given x and y, I and theta are not unique. R could be positive, could be negative. If R is always positive, then it's only unique solution for R, but theta is still not unique. But here we allow pi R negative. All right. So now, now we can describe the curve using polar equations. Okay, if polar equation means the points are determined by the relation between R and theta. Okay. So given R equals 4 secant theta. Okay. Okay. and theta between negative pi over 2 and the positive pi over 2. Right, let's understand the curve describe this. So we want to plot all the points with polar coordinates satisfying the sample equation, right? Right. Plot points with polar coordinates and theta satisfy the equation y I equals 4 secant theta. Okay. So we want to draw a sketch graph for that equation. How do you do that? Of course, you have to choose a bunch of points. You know, the general method, you can let the computer do it, and you will get here's theta, okay? Theta and r, then you do the computation. Theta equals, negative pi over 4, blah, 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 blah. You know, theta is going to be 0, at least. You have to choose this values, right? And then you compute it, and the secant theta is a cosine theta. So cosine negative theta, right? Cosine negative pi, this is okay, 4 over square root 2 over 2, right? Okay, actually it's a 4 square root 2. And this is a 4. When theta, this is also 4 square root 2, okay? Both are positive. Okay. So you get something, but that's not enough. So really, you cannot sketch graphically. So we try to rewrite the equation. When I rewrite the equation, we know that x equals r cosine theta, y equals r sine theta, right? Right. So r equals 4 secant theta. This is equivalent to saying r cosine theta equals 4. So in other words, that equation describes this equation, x equals 4. So what does that mean? That means this is just a line in the xy coordinate system. Okay, all the points are here. Okay, when theta equals pi over 4, it is here. Okay, I is going to be 4 square root 2. And here when theta equals 0, when here theta equals negative pi over 4. Okay, so you get same r. So actually it's describe this vertical line, that equation. Okay. That's it. It describes that equation. Okay. So it's better to find if it's possible, find the equation in x in Cartesian coordinates. Okay. But some equations you cannot. Okay, let's take a look at this equation. Okay. Polar coordinates satisfy this relationship. Okay, and I'm going to convert this equation to a Cartesian equation x, y. Okay. So whenever you see sine 2 theta, right, should be, you see that 2 sine theta cosine theta equals 1. So you will see that 2 r sine theta and r cosine theta equals 1. Right? So that means it's 2 y and x equals. So you get the equation like that. Okay. So the equation you will get the equation we'll get is y equals 2 of x. So this is the 2 lines. Okay. Okay. And then you get the whole line because when x okay, let's think about it, right? If I is positive, theta from theta from 0 to pi over 2, you get this whole piece. Okay. And theta cannot be between pi over 2 and 3 pi over 2. Okay. If I is negative, you can draw the other piece. So so even theta is between 0 and pi over 2, I only get 2 pieces because it allows R to be negative. Okay. R to be negative. So I can even assume that theta equals negative. Theta is greater than 0 and less than pi over 2. Okay. Then you get these 2 pieces already because R can be negative. If R is negative, you get this point. And theta range from 0 to pi over 2. Okay. So here's R is positive. Here's you get 2 pieces, right? Yeah. So basically, I is going to be plus minus. Right? Like when theta runs from 0 to pi over 2. With every fixed theta, you get R. But you get 2 values R. When R is negative, you have to go to the other side. Right. Okay. So now my next problem is given x equals 4 y squared. Okay, I'm going to find the polar equations for the curve. Okay. And there's no restriction on x and y, but clearly y can be, y is between negative infinity and positive infinity, right? X must be positive or 0. Okay. So this is a parabola. Opens to the right-hand side. Okay, clear, right? You know the picture. How do we describe using polar coordinates? Okay, so you want to describe this point, theta, right? Okay. We assume I is positive. Then I think theta can be from 0, negative. This is a positive here, theta is negative, right? Theta can be, sorry. Okay. Right, so let's try to find it. Okay. We know that I equals cosine theta, right? Times y equals sine theta. Using this, we put it into the formula. So r cosine theta, put it into the equation. Here's r square sine square theta. Okay, so from this equation, the first solution is r equals 0, right? Second equation, if r is not equal to 0, then you get this 4r sine square theta. We do have a trouble when theta equals 0, right? When theta is 0, what is the value of this? What is the value of r? Right. Right. So, well, from this identity, you can always, yeah, this is the equation. Right? R equals 0 is only described, you get two polar equations here actually, right? And the first equation, R equals 0, they only describe for one point. The second equation, does it also describe this origin? I think when theta equals pi over 2, right? And so this should be this equation, polar equation. But you don't need to write I equals cosine theta over 4 sine square theta. Right? Can I figure out what is the possible value for theta? Clearly theta for the top part, right? Theta is between 0 and pi over 2, right? I think theta is between negative pi over 2 and the positive pi over 2. You get the whole graph already. Right? Right? Yes. Cosine theta is always positive. Sine theta could be 0, but could be sine square theta can always positive. So this is the equation we get. Okay, it actually contains the origin when theta equals pi over 2, and the r must be 0. So the second equation contains the first simple equation. That's why I just need to list it down. Now we're going to look at some curves which cannot be easily described by equations in Cartesian in XY coordinate system. Okay. So given an equation r equals 1 minus cosine theta. Okay, so this is the equation sometimes we see on the Valentine's Day. What? Some people send a Valentine's card, okay, and just put that equation on there. Okay, we will see how does the graph look like. Okay. It's harder to get the equation in XY. You can try it, right? So So you have, in order, what is R? You're assuming R is positive, right? Look at this equation. I think this is always positive, right? So if I is always positive, and then you can multiply by R both sides, right? Okay. And R squared is X squared plus Y squared. And here R is the square root of X squared plus Y squared. And this is just X. See how complicated it is. Okay. This is the equation. Okay. Yeah. This is the equation we have here. Okay. And can you, it's hard to understand, right? So even you get equation in XY coordinates, you're still not able to see that. This is the first equation we see that. It's complicated. So in order to sketch the graph, I have to draw a line here. Theta has R, okay? Okay. So when theta equals 0, I have to choose some point. Okay. When theta equals 0, I equals 1 minus cosine 0. Cosine 0 is 1, so it's 0. Okay, that's origin. When theta equals pi over 4, this is 1 minus square root 2 over 2. It's a positive number. When theta equals pi over 2, and this was 1 minus 0, so it's 1. When theta equals 3 pi over 4, it's 1 plus square root 2 over 2. When theta equals pi, this actually is 2, right? 1 plus 1 minus negative 1, so it's 2. This is actually the largest possible value you can get. And then keep it going, right? So it is pi plus 5 pi of 4. So this will be negative, minus negative square root 2 over 2. So it's 1 plus square root 2 over 2. Okay. And then that will be 3 pi over 2, 270 degrees, right? So cosine is going to be 0. So it's just 0. And next one will be what is that? Okay, should be 2 pi. I think it's 7 pi. Okay, so this is 1 minus square root 2 over 2, and you come back. It's a 1 minus 1 is 0. Okay, so those are the numbers you're going to get. Okay, and you have to draw plot them in the extra plane. Okay, when theta is 0, this is it. But when theta is pi over 4, and you get a number smaller than 1. Okay. When theta equals pi, you get a 1. So this is a 1. Okay. Now when theta is 3 pi over 4, and that's what we get here, right? This I is going to be 1 plus square root 2 over 2. When theta equals pi, that is negative 2, so it's 2 here. Okay, I is going to be 2. And you come back and you find out it's symmetric. Okay, so you do need a little bit of imagination how to draw them. Actually, you get on the heart. Okay, so that is a graph of that Pauli equation. Okay, and if your brain can do very quick computation, then you just imagine, you let theta increases and you can quickly figure out the value of this arc. Then you plot the point, so you can see the point going to. Okay. Otherwise, you just do it just like as I did, and put enough, choose enough values for the theta. Then you calculate the corresponding values to arc. Then you get theta r, theta r, theta. So you plot those points in the XY plane, and you connect those points, and you get a graph. Okay. Now this equation involves radicals, right? But you can also, you can get rid of that and square both sides. What do you get? You square both sides, then you get no radicals. Okay, so this equation just polynomial in two variables. It's getting more and more complicated. Okay, so this is an equation of degree. It's a polynomial degree 4, right? It is a polynomial degree 4. You can mind this, it's going to be 0. This is a polynomial in xy of degree 4. And it's much harder to describe. Okay, or you can use computer to plot them. You have a graphing calculator. You can plot this. Yeah, you can sketch this graph with a graphing calculator. Probably it contains more pictures than the above one, because why? See, when you square it, right? When you square it, sometimes you get a more you get the equation contains more. Okay, how do I know that, right? For example, equation x equals 1, just 1 point, right? If in the coordinate line, but you square it, you get x squared equals, then you plus minus negative positive, so you get 2 points there. So they're not equivalent. Okay, x equals 1 plus x squared equals 1, but conversely, it's not. So if you want to draw the graph for x equals 1 and draw the graph for x squared equals 1, the graph of x equals 1 is contained in the graph of x squared equals 1. So the graph of x squared equals 1 might contain more. All right. Right. Now, in general, if you have an equation, okay, if you have an equation I equals r theta, right? Then, if the curve is described by this equation, so that means I is determined by this theta, depends. So you get a bunch of curve here, right? You get a point, then you get a curve. But then this curve can be also can describe by Pauli equations, Pauli equations, parametric equations, or parametric equations. Okay. So because I is going to be theta, so parametric equation is theta. Right? So those are the parametric in XY coordinate system for the same curve. So those two are equivalent. Okay? And so you can use this to get even get the tangent line slope, right? How do you get slope? Okay, so at this point, this is a right. Okay, so that is yeah. Sometimes you can always simply write it like this. This is in polar coordinates. Okay, this is here is in Cartesian coordinates. Okay, and you can find the slope, right? The slope of the tangent line. At that particular point. Okay, in Cartesian coordinates, x naught, y naught, right? This is can be given by right. That is a dy over dx. Remember, right? Evaluate these two lines. Okay, but this is also going to be dy over d theta, dx over d theta, and theta could be equal to 0. So you can differentiate. What is y? Y is r sine theta, right? So let's differentiate, right? I is r prime sine theta plus r cosine theta. And x is going to be r prime cosine theta and r sine, negative r sine theta. Right, because the derivative cosine is going to be negative. Right? So evaluate this point. But you can also both sides divide by cosine. You can change this a little bit. And here's r prime sine theta over cosine theta is tangent theta. And that is r prime. And minus r tangent theta. And theta equals 9. Okay. So there you can quickly compute the length. Okay. So given the polar equation, you can always get the Cartesian equation. Okay. Then you can use that to find the length, the slope of tangent line and the length. Okay. So let's do some. I think the next section we also will. We will also discuss the formulas, for the length of the curve. Describe our polar equations. Right, so let's take a look at the problem first. Find given I equals cosine theta over 3. Right. Find the slope of the tangent line. Right. At the point where theta equals pi. Okay. I don't need to draw the graph. Okay. If you want to use above formula, you can find. Otherwise, you can forget about formula, Okay. But you get the parametric equation for the curve. Okay, since I is cosine theta of 3, right? And this is a cosine theta of 3 and divided by sine theta. So you actually you get parametric equations. You get parametric equations for the curve, right? So the slope dy over dx, right, is just equal to dy d theta and dx d theta. So you just differentiate each other, okay? Let's differentiate. And when you differentiate the y with respect to theta is negative, theta over 3, and I think I have to go by 3, right? And sine theta and plus cosine theta over 3, cosine theta. You don't need to simplify. And this will be negative 1/3 sine theta over 3, cosine theta, and then I think that this is a negative because the derivative cosine is negative sign. All right, so this is a expression. Then the slope at that point, you have to evaluate when theta equals pi. So negative 1/3 sine pi over 3 sine pi plus cosine pi over 3 cosine pi. Negative 1/3 sine pi over 3 cosine pi cosine pi over 3 sine pi. Okay, and which one is negative? So I don't need to worry about this. I don't need to really worry about. Okay, cosine pi over 3, cosine 60 degrees, 1/2. Cosine pi is 1/2. It's negative 1. So here's negative 1/3. Sine pi over 3 square root 3 over 2. Cosine pi is negative 1. Okay. So this is going to be negative. What do we get? We simplify. Right. So you get 1/2, and you get square root 3 and 3 and 2 to cancel out, and just square root 3. Right. So that is a slope. Right. Right. That is a slope. So you given Pauli equation, you convert it to the Cartesian equation. Then you use you get a parametric equation. Then you use a formula. You can use that formula to find the length of the curve, find the length of the curve, and find the area of the surface generated by that curve in the xy plane. Okay, is that around the axis or around the y-axis? Right. Right. There are two types of equations we needed to know. One is I equals 2 minus cosine theta, because we already did the I equals 1 minus cosine theta, right? Okay. And I equals 1 minus half of cosine theta. So the graph is, if this one, the graph looks like that, y. In this case, oh, it's the same. Yeah, let me change to 2 here. Okay, so this could be negative. Okay, so the graph the graph looks like that. Okay, So there's three different type of graphs. One on the top is right. I think it's a difficult part is the second one. I'm going to spend a little time to explain to you why. Yeah, let's look at. Yeah, so you have to know you have to understand how do we draw the three graphs. Okay. Let's take a look at 1 minus 2 cosine theta. You will see that when theta is between I is going to be negative. If theta is between, I think between a negative power 3 and a positive power 3. The reason is, here's cosine power 3 is going to be 1/2. Cosine negative power 3 is also going to be 1/2. Okay, 1/2, 1 minus 2 times 1/2 is going to be 0. So imagine, okay, if this is these two angles, okay. Imagine if angles between power 3, your I is negative, so you only draw the picture here on the other side. When theta equals 0, I is going to be -1, so here's -1. So the point is here. So when you start angle here, so you get a picture, okay? So this is when theta increases from here to here, you get a picture, okay? You get a picture of this portion, okay? So when theta equals pi over 2, then I is going to be 1. So you're coming back to here. So I just draw partial there. Okay. Okay. For this portion, okay, for the angle from here to here, then my curve is the corresponding, because I is always positive. So you get this portion. Okay. So this is when theta is between pi over 3 and pi over 2. Okay, here's when theta is between 0 and pi over 3. Okay, so you get this piece. You can put it all together. Okay, so then you will have when angle between from here pi over 2 to pi, and you will see that it's increasing because cosine theta is going to be negative until cosine theta equals -1. So you get 3. So you get a picture like that. Okay. So this part is 3. Okay. That's when theta equals pi. Yeah. This is when theta. Okay, when theta is between pi over 2 and pi. And similarly, I just I decompose the picture into several of them. Okay, and similarly, you're coming back to here to about the symmetry. Okay, so this is a theta between pi and 3 pi. Okay, yeah, this is theta. Okay, so I is always positive. I start from here, I is going to be 3, and here I is going to be 1, back to 1. Okay, then I is going to be 1 minus 2 cosine theta, right? Then you have a problem here, right? So this is a theta between 3 pi over 2 and I think it's 2 pi minus pi over 6. pi, 2 pi minus pi over 3. So this is 5 pi over 3, right? So from here, actually, r start equal to 1, and then I equals 0. So you get picture of this portion here. Right. So that is clear. And okay, then the angle from here to here, right? Theta is between 2 pi minus pi over 3 and 2 pi. And this time, cosine theta is too large. So you make r equals 1 minus 2 cosine theta negative. Okay, so you have to draw the point on the other side. Okay, so it starts from this all the way to here. Okay, going that direction. Okay. Finally, yeah. So you put all those, how many pieces here? 1, 2, 3, 4, 5, 6, 7, 8, yeah. No, so 6, yeah. 6 pieces. You put all these pieces together, then you will get a picture. You know, when you draw it, it looks like that. Okay, this is my starting point. Okay. Okay. So yeah, so you get okay. 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 So that is a picture you will get. Okay. So the heart is kind of like a twisted. Okay. All right, so I'm going to stop here.